You're such a good boy. Yes, you are. Yes, you are. All right, and here we go. Our guest can't hear me yet, so I'm going to fix that in a second. But we're going to talk about, in a second, things and stuff. All right, Carina, you should be able to hear me now. We're live. All right, I think I'm going to have to turn you up a bit, but that's okay. That's okay. We have the technology. So, did you know what Twitch was before this? Oh, fancy. I went to AAS and AGU and I kept having to explain what Twitch was to people. So I'm totally ready to answer that question for most people. Okay. Make sure, oh, they can't hear you. Oh no. Okay. There. Now they should be able to hear you.
Okay, is that better, everybody? Oh, I can hear me now.
Yeah, I was gonna say, you might want to mute Twitch. There we go. So there's always a little bit of confusion once I pull Discord in, because of all that. So are you watching chat too?
I am.
Okay, good. Good. Because they will probably ask questions that I won't have the answer to. So turn your volume up a little bit. And there's Keeper, who crashed our channel, or who crashed us a little bit ago. So hello, everyone. Hi, Bill Link. So there are two voices today. And there's one moving face and one static face. So the static face behind my webcam view is of Carina Bennett, and that's who the other voice belongs to. When we switch to another screen, I should have something that'll tell you which one of us is speaking. But essentially, if you hear a voice and my lips aren't moving, it's not me speaking. I know it can be a little confusing when there's only one webcam, but this was the easiest way to set everything up for me. And check. So people are probably going to trickle in. That's just the nature of Twitch. And try to make sure I have everything ready that I need to have ready. And we're probably going to do a lot of repeating of stuff. So that's just how it is. So are we ready to do this thing?
Ready?
All right. And heads up in the audience, if you need me to adjust audio, let me know. I'm adjusting it to the best I can. Oh, look, there's bits already. So they know what bits mean. I don't think you know what bits mean. So let me find it. All right, Puck. The dog's gonna bark in your ear, and I am so sorry, Carina. All right, Puck, speak. Come on, speak. Really? That's weak. Come on. There we go. Puck says thank you. I say thank you. Here's the Cheerios, and make it rain. And there's Cheerios stuck on jackets. All right. DPI says that's okay. Mapping Bennu is a lot of repeating stuff too. Oh, I forgot to put the dog up. All right, so there's the dog watching. Or there's the dog eating the Cheerios that Keeper of Maps donated. So, I have never interviewed anyone before, so this is going to be a little weird for both of us. Hooray! So why don't you go ahead and introduce yourself, Carina?
So I'm Carina Bennett, and
I'm so sorry. I was mispronouncing your name.
I am an image processing engineer on the OSIRIS-Rex mission, and I have been CosmoQuest to build this mapping application for people in the public to use to help us find rocks and boulders and craters on Bennu.
So how'd you get involved with the OSIRIS-Rex program?
So I actually started on OSIRIS-Rex when I was a student at the University of Arizona. And I was a computer science student, but I had a background in film and video and poetry. And I was getting another undergrad degree. And I started as a student, and when I graduated, they hired me into the image processing team.
Oh, that's so cool.
Which was perfect for my film and video background and my computer science background.
That is so cool. So did they just come around to the undergraduate computer science people and be like, hey, there's this project? Like, how did you even find this?
I found it, well, it's based out of the University of Arizona, so we all kind of, it's part of University of Arizona life. There's a lot of promotion for it, which is great. But I actually worked in the university PR department before, making videos, to the interesting science and the interesting research that's happening at the university. And so Dante Loretta, who's the PI of the OSIRIS-Rex mission, when I got that job, it was like 999 days until launch. And Dante Loretta was one of the first people that I interviewed.
Oh, that's cool.
Kind of introduction to OSIRIS-Rex. And that was about 3 years before I started working here.
Oh, that's so cool. I love how undergraduate jobs work out like that. So we've talked a bit about your background. I really do apologize. I have never interviewed anybody before, so we're just going to kind of bumble along the wall. Paranor's making a comment about 99 days on the wall. Just get to sleep, wake in the morning, 998 days on the wall. So, all right. So I am going to flip over to the tutorial. Actually, we might try to skip the tutorial. So we ran through the tutorial earlier, and I'm just going to go ahead and run through the tutorial again, which I already find very annoying, so never mind. We're just going to skip it. So I have up on the screen for everybody right now a picture of, like, stuff on Bennu. Like, before OSIRIS-Rex got to Bennu, what were you guys expecting to see?
We were kind of expecting to see what you all see in the tutorial. So those were computer-generated images that we created before we got to the asteroid to help us test our software and test our processes. And honestly, that's kind of a little bit what we expected to see. Choosing a sample site to be obvious and immediate, that there'd be big swaths of smooth area like you see on Itokawa or you see on Eros or even on Comet CG, you see these areas. That's just obvious from the get-go that, like, that's where we're going to go and sample. Of course, you guys can see, even in this image, what we actually encountered.
Which was not at all how I would have pictured an asteroid. Like, is there any clue to why this is so rocky compared to Itokawa?
I'm not sure why Itokawa and Bennu are totally different. I mean, we did discover that Itokawa is a rubble pile, which my understanding is that Itokawa is also a rubble pile, but that explains why Bennu is so rocky. And Bennu actually looks a lot like comet or asteroid Ryugu, which is the Hayabusa 2 mission's target asteroid. They're also sampling and bringing back material. So we've had a lot of between our two missions because the asteroids do look so similar.
So is there a lot of, do you exchange a lot of information with the Hayabusa mission, or you guys collaborating with them, or?
We do. We actually have a partnership with them, and quite a few of our scientists are also on their team. So they send scientists here, and we send scientists there, and we compare what's going on, and we, talk about like things that we have learned from our missions that can help the other mission and compare.
That's really neat. Has there been anything from Hayabusa that you guys were able to apply to OSIRIS-Rex or vice versa, or anything in particular?
The things, at least for this project, is that we saw Ryugu before we saw Bennu. And so that gave us a little taste of what we could end up seeing, which was a very, very rocky surface, which is so being able to see their data and make plans for, well, what if that's what Bennu looks like, ended up being very helpful.
Miss Town is making a comment of, oh God, more rocks, no more rocks. Star Strider replies with, it's rocks all the way down. So, Star Strider made a comment earlier in my daily space stream that Bennu literally ejects debris, and I know there were a couple of people concerned that debris would hit spacecraft. Is that something to worry about at all?
There is a chance that debris could hit the spacecraft. So it is ejecting material. Some of the material is getting ejected completely off and going off into space. Some of it's getting ejected and then immediately falling back onto the surface. And then some of it is actually and then getting caught briefly in orbit. So it basically turns into a very small moon. But fortunately, spacecraft for space, and there's a lot of stuff floating around in space at very high speeds. So the spacecraft that we observed are going slow enough that they're not actually going to damage the spacecraft if they hit us. So we're just taking that as if we get hit, and we're going to be fine. So we're not really worried about when we go to sample if we'll get hit or not.
I guess that's definitely reassuring, because there are a lot of people like, oh no, what if everything gets hit?
We'll just take it. It's a tough little machine.
It sounds like it is. So these rocks that are coming off, that they're not moving too fast. They're just kind of, it almost sounds like some of them are drifting away. Or they're somewhere in between? Yeah, so they have short lifespans. They get caught in orbit and then very slowly kind of until they land back on the surface. And I can't remember exactly how fast, but I think it's something like a slow toss of a softball. Some are centimeter size. I think the biggest ones we've seen are about the size of a softball. Oh, okay.
Not terrifying.
Okay, so not super terrifying, more like just softball being played almost on the surface of a very, very rocky small body. That's interesting to think about. Keeper of Maps is asking, what are the rocks made of? Is there any idea of their composition? I kind of joked earlier that if there were scrappers on Bennu, that if there was any iron or copper, that they would have dug all of that out by now.
Obviously, one of the things that we're really interested what these rocks on Bennu are made of. And one of the things that's super interesting is that we can see, if you look at the images, we can see very dark rocks and very bright rocks. Which isn't really what we saw in Rugu. So this is something new that we're discovering. And the teams are working extremely hard on figuring out what they're actually composed of and why they're different. And we know it's a carbonaceous asteroid, and that's why we went there. And geology is not my field. Specifics, I don't have a lot of information on that, and they're still working. It's tough in doing everything remotely sensed with these instruments, to be sure. They're working through the science of it right now, and they'll do publications as it comes out.
Okay. So you're the image processing person on all of this. What exactly does that entail?
Image processing, there's 3 photographic cameras on the spacecraft that are used for mapping. And so a lot of what we do is actually the mapping of the asteroid. So we take a whole bunch of images, and and we map project them into either equirectangular or sinusoidal, any kind of regular map projection that you guys have seen of the Earth or of Mars. And so we take a whole bunch of images, like exactly the ones that you're looking at. The ones in the Bennu Mapper's site are the ones that are actually going to go into the global Mosaic, which is one of the products that I'm working on right now. And so we take a whole bunch of images, mosaic them together. We can also take images at different angles, and we can turn those into stereo images, so we can make the images look 3D. We also, we get raw images off the spacecraft, and there's a lot of space that can damage the CCD chip slightly. So we can go through and correct those images if there's a hot pixel or a dead pixel. Part of our job is to make sure that these raw images come off the spacecraft and get fixed so that they don't have any obvious blemishes, or we can, flag areas where the data might be corrupted, things like that, for mapping with the images.
That's Puck. It's okay, Puck. My dogs have opinions. Go outside. If you don't want to talk about Bennu, go outside. Okay, I just threw Cheerios. Hopefully that'll keep them busy. So Keeper of Maps is wondering, and I am too, if you know the dimensions of the image on the screen in Bennu Mappers, and if you don't, what are the dimensions of the images that are captured by the cameras on OSIRIS-Rex?
So the images that you're looking at on Bennu Mappers, they're right around 5 centimeters per pixel, and they're 450 pixels across. So pretty much a resolution limit of about 20 to 21 centimeters. So that means it takes about for you to actually be able to see something and identify it as an object. And so basically everything you're mapping is about 21 centimeters or larger, which is great for us because that is the limit of size of the sample head that anything bigger than 21 centimeters will actually clog or cover the sample head. So that's one of the things that everybody is helping us with, identifying things that could actually disrupt the sampling process.
Oh, wow. So it sounds like the ideal landing spot or touch and go or whatever you want to call it spot is one where there isn't all of this stuff. How are we going to find that? Because all the pictures I've seen, it's just rocks everywhere.
It's been a challenge. And so, yeah, obviously our ideal spot would be you would have that entire image and it would look just like a gray blob with nothing. You couldn't see anything. And unfortunately, with the way that Bennu is, we don't find any spots like that. So we're both looking for any spots that are particularly smooth and also looking for spots that are kind of smooth, but we can still safely navigate with just a little extra precision in the way that we're going to do the sampling. Definitely need to look for anything very large that could
clog the intake.
Clog the sample head, but could actually, damage, or if the spacecraft hit it, it could, take it off of its trajectory, things like that. Or every single one of those rocks are.
So is it more important to mark boulders or more important to mark the smaller rocks?
Everything is important.
Everything is important. Oh,
everything is super important. I mean, boulders are very important. Boulders give us orientations of rocks, which is also very interesting. But knowing where all the small rocks are, you know, there's probably less people who are going to spend time getting all the little teeny little rock cracks. So if you're that type of person who wants to sit down and do that, that is great science for us.
So essentially, it sounds like the boulders are interesting to have marked because, okay, you can see the rock direction, but as far as collecting samples, you really need to know where all of those small rocks are.
Exactly.
Okay. So, and let's, I want to back up a little bit. So you keep mentioning the sample head. What exactly is that? Is that like a vacuum head that can get clogged? How are the rocks or samples, I shouldn't say rocks because we're not going to collect rocks. How are the samples going to be collected?
Sample head is actually a really cool design. So you kind of have to imagine it like a donut-shaped basket. And it's on the end of something that's not exactly a pogo stick, but very much like a pogo stick. So it has a arm, and that bend in the arm can compress and release just like a pogo stick does. And so what we're going to do is we're going to start our approach and slow the spacecraft down until it's just kind of the momentum of the body moving. And we're going to press up against, only going to be in contact for 5 seconds. And during that 5 seconds, this donut-shaped basket, and inside of the basket, it has kind of a meshy material so that things can get caught. So we're going to release a puff of condensed air or compressed air. And that compressed air, while we are is going to kick up all that material, and that material is going to get kicked up and caught in the basket part. One of the things that when we get closer, we're going to have to look for, so you guys can see down to about 21 centimeters in these images. We're going to do another pass once we pick the two potential sample sites. We're going to do really, really close-up mapping and imaging. And then we're going to find everything down to 2 centimeters. And our hazards become things that are 7 centimeters.
Oh, wow.
And 7 centimeters is important because if we hit a 7 centimeter tall and we tilt, and then we push out that air, instead of kicked up into the sample head, we're just going to blow it all out the side. So after this campaign, you know, we're going to have to do more mapping in the future at even higher resolution.
Oh, wow. The software is being a little
These rocks are very important to us.
How big is the sample head?
Inside of the sample head, so the inside of the donut, is 21 centimeters. So about the size of a dinner plate.
Okay. And anything larger than 7 centimeters, it sounds like it can do damage or just make things happen in ways that we don't want it to happen.
It can make sampling more difficult.
Okay. Oof. All right. So Keeper of Maps makes a comment as I'm envisioning that this retrieval thing is kind of like a wasp trap. I'm not entirely too sure what a wasp trap looks like, so do you?
Kind of imagine it almost like if a wasp trap is similar to a fish trap, there's a big opening, and then the fish or the wasp or the material, it gets stuck in the sides and they can't come out the center anymore.
Oh no.
Is that?
Okay. Yeah. That makes more sense to me. That makes way more sense to me. Yeah, I could see that happening. So, how many, and they're linking animations in chat, so let me actually click on a few, which should bring them up. So on screen right now, I have an animation of what the collection head will do. And you're giggling. Why are you giggling?
love this animation. So that those dotted lines with the arrows, that's the compressed air getting pushed out.
Okay. So that's
You
one
see
of
the air goes up and it goes into the center of the sample head, and all the stuff gets kicked up, and then it gets caught in the sides, and the sides are kind of that donut baskety area that I was talking about.
Okay. And what's the largest size particle you can capture with that?
It's about 2 centimeters.
Oh wow, that's
Under than
tiny.
2 centimeters. And on the bottom of the sample head, we have this stuff that's like industrial Velcro. So we have these little spots on the bottom, and those will actually just pick up dust particles. So
Oh,
we can get
cool.
all the way down to dust size, and we can collect that as well.
Oh, that's so neat.
Well,
Loopy,
to us.
yeah. Loopy Dragon says it's collecting by blowing against it. An asteroid kiss.
Yeah.
Yeah, that's I think that's a neat way. So we shared another one. Oh, it's the same. I feel like it's the same. Oh, this is just more detail. But it doesn't show the cutaway. It's just here. We're going to land. Things happen. And they highlight a part. Yeah, so this animation isn't as useful as that one. So scroll up, see if there's any other questions in chat. I don't really see any other questions. So back to mapping while we chat. So I saw a couple craters, or what looked like craters. Would those be potential target spots? Like, how large of it? So you said the retrieval head is 21 centimeters, so the size of a dinner plate. How large is a target area?
Before we got to the asteroid, we wanted an area that was 50 meters across without a single rock that was 21 centimeters or larger. And you can see that we're never going to find that. So they've been redesigning the approach for the sampling, and it's just getting smaller and smaller. So it's under 10 meters at this point. And we're still working on getting that smaller. I mean, the smaller we can get it, the more options that we have.
Oh, wow.
So that's something that we're actively working on.
Oh, wow. And without... So it looks like maybe some of the craters be possible, like... But I know at least one
If
of
you
the
click
craters
through the images, you'll see some big craters that pop out that we're definitely looking at.
This one's all... Part of me is like, this one's all rock snow. There's part of me that thinks maybe it would be easier to just mark spots that aren't rocks.
We have also talked about that.
Because now I'm just going to click through it. I know eventually the software is going to get mad at me. As I see spots on this particular image where it doesn't look like there's too many rocks, but have you seen any spots that aren't rocks? Do you have a set of target areas already?
We have some areas that we're kind of going through methodically with all of our teams, and it was around 50 when we just made the big pile of options, and we're very slowly going through all of them and eliminating them or making them, marking as very interesting. And so, yeah, we have some areas that we're looking at, but, the whole asteroid, and we also don't want to bias people. We're interested in what the public can find.
Gotcha.
So having you guys look at all of the images is also very useful.
Part of me is like, but it's so much easier to just mark where there's not rocks. Maybe, will that be... Well, actually, you said once you identify a couple target sites that will have more, I guess, zoomed-in pictures that will have... they're taking closer, so it would be kind of useful then to be like, okay, go mark everything. Because I'm flipping through these images.
So we're actually physically going to fly closer to the asteroid and take those really high resolution images of just 2 sites.
Okay.
And also there's future science that we want to do with these images. I mean, nobody's ever year this close to such a small body. We actually have the Guinness World Record now for orbiting the smallest thing in space ever orbited.
Oh, wow.
Okay.
Okay.
So this is just a ton of images and a ton of data that we're going to have access to. Exciting to do continuing science even after we pick the sample sites. Like, there's so much here to look at.
And Starter's joking that shouldn't it be the Guinness Solar System record? Wow.
Yes. We need to update that.
Yeah, we totally do. A couple people have asked a couple times how many attempts you can make to collect the samples. Do you really only have the 2 attempts? What happens if things go wrong?
We have 3 canisters of air.
Okay.
And each sampling attempt uses 1 canister. So once we use all 3, hopefully we'll use 1. Our requirement is to get 60 grams of material. So if we can go down once, release 1 can of air, and get 60 grams or more, we are happy. We are thrilled. We're coming home. We can also do... So we can practice a few times without actually touching the asteroid and without actually releasing the air to get a better idea of how successful we'll be. So that's another thing that we're going to do.
Well, even if you just touch the asteroid on those attempts, sounds like with the Velcro you'd collect a little bit of dust at least.
We will get some dust particles.
Do you know what the minimum... I mean... You said the goal was 60. What happens if you get less than 60 grams of material?
Hopefully we don't. If we do get less than 60, we're out of attempts to come home with what we have. Be unfortunate, but, you know, space science is very hard. And it's possible, but expect to be able to collect the material that we're expected to collect.
Okay. Is the whole craft coming back?
The craft is coming back. The only part that's actually going to come back to Earth is there's a sample return capsule, and it's actually the same design that was used during the Stardust mission, which got the dust from the comet's tail. So it's kind of tried and tested and has been successful in another mission. So what's going to happen is the spacecraft is going to come back to Earth, get into an orbit around Earth, and then release the sample return head, or the sample return capsule, which will have the entire TAGSAM head inside of it. And then, so that's the only part that we're actually going to ever see again as far as us on Earth being able to touch it.
So no hard drives coming back, no spacecraft bits. I'm assuming end of life is just for it to kind of orbit, or is it going to, do you know if it'll drift off into space, fall into the atmosphere? Do you have any idea what happened with the actual spacecraft?
There will still be fuel and there will still be instruments on the spacecraft, so there is potential for a continuing mission. We're not planning for that right now. Nobody's focused on it because we're focused on the OSIRIS-Rex mission. But the spacecraft will be operational if somebody can come up with another with it.
That's actually pretty cool. Loopy Dragon is, I'm assuming he's talking about the maximum amount of material. Do you know what the maximum amount of material that can be gathered? You say 60 is the goal.
50 grams is our goal, and 2 kilograms is the maximum that we've tested it being able to hold.
Oh, wow. That is quite a difference.
It's a range for sure.
That's quite a difference. Do you know how much material Hayabusa brought back? Did they use the same collection mechanism, or did they do something different?
Hayabusa 2 mission has not come back yet. They're still in operations around the asteroid.
Okay.
So we don't know how much material they managed to get. And Hayabusa 1, which went to Etakawa, I don't actually know off the top of my head.
Okay.
But it was a small amount. It was less than they were hoping.
That's unfortunate. It's very unfortunate. Loopy Dragon made the comment about, I'm sure 2 kilograms would make a lot of people happy. Indeed. So what's going to happen to these samples once they return to Earth safely?
Samples are going to be housed at the Johnson Space Center, where, like the moon samples are housed. But they will be available for research. They'll be partitioned out, so there'll be a small amount of the sample available for research now, and the rest of it will be preserved and archived in the hopes that in the future technology will get better and we'll be able to get more information out of those samples. So we don't want to use them up now and damage them.
Right.
So we want to be able to save them for hundreds of years as technology gets better, and we can continue to learn from this one mission.
Right. Yeah, because I think I remember reading that they recently discovered new things using the lunar samples that previously had not been known because, as you said, technology got better.
Very, very cool that we can, we'll be influencing things hundreds of years from now, hopefully, and people will be discovering new things.
Will any of the samples be, I'm not sure what the term is, available for you or available for viewing by the public? Or is that something that's likely to happen to samples after they've gone through sciencey things?
I really don't know the answer to that.
Okay.
That would be interesting. The sample, it's coming back to Earth on September 24th, 2023.
Okay.
So it feels so far in the future. Really exciting for people to be able to go and see them.
Yeah, because I'm thinking of some of the programs that exist, like getting a piece of aerogel to display. I know NASA's allowed pieces of shuttle tiles to be displayed. I think some lunar samples have been displayed. Like, I'm thinking of all of these things that, were part of missions or came from missions that eventually the public were just able to see. And I think some lunar samples are actually preserved in like acrylic. So after they've done all the science and there's, it's still cool to look at, but you can't get any more science from it or it's already considered contaminated. Things of that nature. So that's what I was thinking of. So Loopy Dragon is asking, the OSIRIS-Rex mission and Hayabusa teams exchange data, right? They're asking if that'll extend to samples. Will you trade X grams of each other's asteroid dirt?
Do have plans to exchange material between each other. I don't know exactly how much, but it's already decided how much exactly how much material each team is going to give the other team.
Oh, that's really cool. Do you know if it's a fraction or a set amount?
Don't know off the top of my head.
Okay. That's fair. part of me would be afraid of it being a particular fraction, because what if it's a whole lot of material? Then you end up with a whole lot of material, but if not a lot comes back, then not a lot. And, you know, if they don't retrieve equal amounts, then that's not entirely fair if one team gets 2 grams and another gets like 0.2 grams. So, does anybody else watching the stream have any other questions? Because I'm not even too sure what else to ask you. Like, we've talked about what's more important to mark, and the answer is mark everything for science. Like you said, the mission's not coming back until 2023. Oh, when's the target date for collecting the samples?
We are going to actually sample in July of 2020.
Oh, wow.
So we're going to choose the samples. We're going to choose the 2 sites in July of 2019, so just in a couple of months. And then we'll have a year of preparation to actually maneuver and then do the sample.
Oh, wow. So you're going to select, it sounds like you're going to select the sites later this summer, and then next summer, for those of us in the northern hemisphere, collect, or not collect, try to hit the targets. Am I understanding that right?
We'll select the 2 sites this year, and then next year we'll actually go down and
hopefully suck up some material. So, Loopy Dragon makes the comment of, I imagine this Bennu mapping program will have a lifetime beyond helping them inform the choice of landing site in terms of scientific value. Yes, earlier she mentioned that knowing the direction of the boulders does what exactly? Can you refresh my memory?
So the continuing science that we can do with these counts. So first of all, we'll have a global count of on the asteroid that's greater than 20 centimeters, which is incredible. Like, we don't have the manpower to do that globally. So having that data from the public is going to be extremely useful. And we can use that to get the size frequency distribution of the boulders globally, which can tell us a little bit about, like, is there more large material? Is there more small material? And that can give us hints about what the entire composition of the asteroid is. We can get boulder orientations. So that can tell us if you've ever taken a box of long, skinny things and shook it in one direction, you can see the material line up. So looking at the way that the rocks are oriented, we can get a little bit of information if there's any kind of shaking or movement on the asteroid. And these are all things that we wouldn't be able to do without the global counts.
That's pretty awesome. And how would you define the difference between a rock and a boulder on this program? Because I'm looking at a couple on my screen right now that potentially could be a rock and potentially I could mark as a boulder. Like, where do you draw the line between the two?
Easiest way with the app to determine if it's a rock or a boulder is there's a limit to how small of a boulder you can draw. So if you try and mark it, the tool won't let you mark it, then that's a really good candidate to mark as a rock. Okay. And if the boulder can mark it, then it's big enough to be considered a boulder.
Right now, it doesn't look like there's any minimum limits, so maybe that's something that we kind of need to poke at. Susie just points out, yeah, this program can lead to all kinds of scientific value. We don't even know what kinds of important info we might learn until later. Loopy follows up with, do you have a personal favorite terrain feature on Bennu so far?
One of my favorites, the mission has been calling it Gargoyle Rock. I think there was recently a Twitter image of it, but it's a really dark really tall rock, and it has a little white rock right where like its eye would be, if you can imagine it sitting up.
Oh, that's so cool.
And that one's one of my favorites. It's kind of a mission-wide favorite. We all really like that rock. You can see the dark material, you can see the really bright material, and you can, look at it and see a little gargoyle sitting there.
That's really cool. Are regions of Bennu going to be named? Have you already started naming regions of Bennu?
We are actively working on that. It is everything with an official name has to be approved. We have a theme, a naming theme. I don't know if the theme has been yet, so I probably won't say it.
Okay, that's fair.
This is recently released of the team. But yeah, so anything, I think it's greater than 5 meters can potentially have an official name.
Okay, so I have an image up from what looks like the official OSIRIS-Rex Twitter. Is this the Gargoyle Rock?
That looks like it.
That looks like
the Gargoyle Rock. So you can see
Rock?
the little bright rock perched on the side of it.
That is actually really cool.
You can see from the shadow, like it has a very, very long shadow, which tells us that it's very tall compared to the...
Yeah, but it's still as dark as charcoal. That's kind of wild.
So all of these images, even though it looks like, I guess that's what it looks like there's very bright rocks and very dark rocks. I mean, this whole thing is, if you looked at it and just with your eyes, it would look like asphalt.
Okay.
Just extremely, extremely dark and black. So we stretch the images so that we can see the features better.
Okay, so like how when you're working with, well, I imagine these would all be fits images. So you've just kind of separated the dark and the light more, I think.
Yeah, we've made the bright areas brighter and the dark areas darker.
Okay. So this is not what it would look like to our eye. It would look more like asphalt. That's kind of interesting. You're like, oh yeah, this looks like a bunch of rocks, but if I looked at it, it would really just look like, I guess, a gravel road. Or just super dark.
It's easy to forget.
It is. All right, so is there anything that we haven't talked about that you want to share?
I don't think so. I mean, we're going to take a big, and we'll be gathering data from these counts that people are doing with CosmoQuest for the whole next month. And then the last poll that's actually going to contribute to our, what we call the global map of hazards, will happen on July 10th. So if you want your counts that you're doing to actually a map that we're going to use for sample selection, have them done by the 10th.
Oh, wow.
Okay. The site will still be up for the continuing science count, but that's the one that's going to, be the exciting sample site selection.
Okay, so essentially, if you want to help pick a landing spot, do all your mapping by the 10th. Got it. And I think... Oh, there's the NASA press release. So pull that up on the screen for everybody to see. And look, it's another Bennu image. And here's the official NASA press release. It's a polycam camera. It just kind of boggles my mind because without really knowing the scale, it just looks like a really close-up view of gravel. And
everything, it looks like it's just in your backyard.
Yeah. Here for this.
These things are meters big and just massive, size of cars and trucks and.
Oh wow. Yeah, for this one image, it says for scale, the large light-colored boulder at the top of this image is 4.8 meters tall. And they're talking about this one. So that's a couple of people stacked on top of each other. So do we know what the composition is all the way through? Do you expect the entire asteroid composition to just be a bunch of rocks that have somehow stuck together? Do you think there's a solid surface under all of this?
We believe that it is a rubble pile, so it's just a bunch of, all the way through, it's just a bunch of boulders loosely held together. And there's not like a real solid core like, the Earth or one of the bigger planets.
Oh, wow.
Objects has. So just kind of loosely held together.
Oh, wow.
It's just rocks all the way down.
Yeah, Pamela does keep saying it is rocks all the way down. Oh, wow. Paranor is asking, does OSIRIS-Rex have ground-penetrating radar?
We have a LiDAR and we have an X-ray instrument. And so I can't go into crazy detail with them, but
it's okay. So I know LiDAR can be used to kind of get distances to things. What do you do with X-rays and an asteroid?
I don't know what they're using.
Okay. All right, that's fair. I think I'm gonna do last call for questions because we've been doing this for about an hour, and I know I ran out of things to ask. Oh, except for, is there eventually going to be a 3D model of Bennu released, even though it is just a rubble pile? So Starstrider's saying the answer is yes. I think I lost our guest.
Can you hear me?
Yeah, now I can hear you.
Okay. Okay, awesome. I can hear you for a second. There's a shape model?
Yeah, is there going to be a 3D model made of Bennu, even though it's one big rubble pile?
There is, and I believe that it is available online if somebody at home wants to download it and use their 3D printer and actually print it off.
Oh, that's so cool. That's so cool. And for those of you that don't have 3D printers at home, sometimes your local library might have one, or your local university, so it never hurts to go find somebody and ask if you can use their printer. So, aha! Paranor comes up with a link. Hi, Sammy, and here is, this looks very smooth. Oh, because it was added in 2016. Oh, no.
I think either on our website, which is asteroidmission.org.
Okay.
I think it's on that website, or maybe tweet about it from our Twitter account. But I'm pretty sure that we've released our mission shape model.
Look at me not knowing how to type. There we go. Better 3D model. There we go. Paranor's got it. Yeah, that looks like a much better 3D model. That's a 75 centimeter shape model. That's actually a decent size.
Yeah, there we go.
And for comparison, just kind of drag my tabs around. For comparison, this is the other 3D model. Come on, load. It's not going to load. Anyways, there was an attempt. Here we go. So this is the model that was released in 2016 when I guess the team thought everything was going to be smooth, like the other asteroid that Hayabusa 1 had visited. And then this is more of an updated one done within this year. So what a difference like 3 years makes. You can definitely see a whole lot more rocks and things, and this one's not nearly as smooth as the older one. Oh, and if I scroll down, there was an even more preliminary one. Oh, this is cool. So this is neat. I actually like how the team did this. So at the bottom, if you just keep scrolling down, you see the older models, and it actually does let you see the progression of things.
And it's only going to get higher resolution as we, you know, as the year goes on.
That's really cool. All right, audience, this is your last chance to ask questions. Because there's a delay, we kind of have to wait for them to type things in and things of that nature. So, as a reminder, do you want to do the brief who you are for everybody? Because I know some people have streamed in.
So I am Carina Bennett, and I'm an image processing engineer with the OSIRIS-Rex mission. And today we are launching the Bennu Mapper site, where we're asking the public to help us identify rocks and boulders and craters on the surface of asteroid Bennu.
Oh, right. And I'm not seeing any questions. So, yeah, if you missed it and you want to help select the landing site, go to bennu.cosmoquest.org. There's the address right there on the screen. You want to do all of your mapping by July 10th for it to count for selecting a landing site. After that, the project will still be up because there's a whole lot of science we can get for these images. I know it is a bunch of rocks. I know it's overwhelming, but the placement of these boulders and rocks really can tell us a whole lot about this teeny tiny world that apparently is just a rubble pile floating in space. So, thank you so much for joining us, Carina. I am so sorry. I'm probably mispronouncing your name.
It's Carina. You had it right.
Okay, awesome. Good.
And thank you so much for having me on.
Oh, it is amazing to actually chat with scientists behind the images, because I know with other projects we've just kind of gone and circled craters and not really known why we were circling craters, and now we have a better understanding from you, thanks to you, of why we're doing what we're doing. So this is super cool. Trying to find my thing. So I flipped over to chat mode. So I'm going to start the Great Wall of Text. Thank you again, Carina, for joining us. So this has been a presentation by CosmoQuest. Normally we stream 1 p.m. Eastern. Right now that's 1700 hours UTC. Sunday through Friday. We do not stream on Saturdays. Monday through Friday is daily space. Sunday is myself colorizing space telescope data. And give us a follow if you want to be notified of these sometimes random streams, as well as launches and other behind the scenes stuff that CosmoQuest does. If you've ever missed an episode, we archive them on YouTube after a day or so if you miss it on video demand. And I have to think about this because it's a really long wall of text. So this is hard and I'm tired. So our host institution is PSI, that's Planetary Science Institute in Tucson, Arizona, working in collaboration with Youngstown State University here in, I think it's warm again, Youngstown, Ohio. And thank you everybody for all of your support and all of your patience, and go map Bennu, because it is rocks all the way down. And I think that's all the things. So thanks again, everybody, and I'll see you on the flip side or something. I'm really struggling. I don't even think I can do the credits today. Okay, so I got the credits ready, so I'm going to roll the credits, and then we're going to be gone. So have a wonderful insert time of day here, whether that's morning, day, afternoon, evening, or night. Be kind to each other, and if the skies allow, look up. Until next time, bye!